My name is Haikal bin Alia and I will presenting the introduction of Pelton wheel turbine experiment. Pelton wheel turbines are a type of hydro turbine, specifically an impulse turbine that are commonly used in hydroelectric plants. In a Pelton turbine, the water is flowing rapidly and the turbine derives the energy from it by slowing it down, making it an impulse turbine. The construction of a turbine is fairly straightforward. A large circular disc is mounted on some sort of rotating shaft known as rotor. Cup-sized blades known as buckets are uniformly spaced across the circumference of the wheel and are mounted on this circular disc. Around the bottom, the buckets are usually placed in pairs. After that, nozzles are placed around the wheel to introduce water to the turbine. This nozzle shoot water jets in opposite direction of the turbine wheel. The effect of the water jets on the bucket cause the turbine to spin. In this experiment, fully open nozzle is set. Problem statement. The Pelton wheel turbine are used to generate energy using water velocity. The flow rate of the water to achieve certain efficiency is unknown. In this experiment, fully open nozzle is set, hence the velocity of the water will be constant. Rotational speed of the turbine is needed to be measured to achieve acceptable efficiency. The objective of this experiment is to study the operation of Pelton wheel turbine and determine its efficiency, power output generated, flow rate of the water, and the rotational speed using tachometer. The scope of the experiment. The measuring data of the experiment, which are flow rate of water, rotational speed, and power output, are only in lab scale. Fully open nozzle is set, hence the sphere is not needed to be moved.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Farhana binti Muhammad Rani. My ID is MA1711. So I will present chapter 2, which is background theory. Next, this is a theory about the Pelton wheel turbine. Pelton wheel turbine is tangential flow in the past, which is water pressure energy is converted into kinetic energy. It forms a very high-speed water jet, then hits the wheel to help it rotate. In a Pelton turbine, the water flows rapidly, and the turbine derives the energy by slowing it down. Okay, the formulas for the Pelton turbine. First is hydraulic efficiency. Hydraulic efficiency is ratio of power generated by the runner of the turbine to the water energy supply, which is this is a formula. The efficiency of hydraulic equal to power developed divided by power supply at turbine inlet. The next, second is hydraulic efficiency, which is power available at the shaft to the power produced by the runner. So this is the formula, which is hydraulic efficiency equal to power at the turbine shaft divided by power developed. So next, the third formula is volumetric efficiency. This means ratio of actual quantity of water on the runner blades per second to the net quantity of water supplied by the jet. So the formula is efficiency equal to the quantity of water striking divided by quantity of water supplied. Next, for the overall efficiency, ratio of the power available at the shaft to the net power available at the base of the nozzle. So the formula is efficiency equal to the power available at the turbine shaft divided by power supply at the turbine shaft. So next is formula of flow ratio. So it is defined as the ratio of velocity flow at inlet to the energy inlet. So the formula is given as follows: CV equal to V1 divided by the root power of 2GH. Next, formula of speed ratio. Okay, the ratio of peripheral velocity to the energy at the inlet. So the formula is K equal to U over the root power of 2GH. For the formula of peripheral velocity, the velocity at the inlet is equal to the velocity at the outlet. So the formula is listed as U equal to pi multiplying with T and multiply with N. It divided with 60. Okay. So next, so that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syudir bin Syafuddin. Today I going to explain the procedure of the determination of the performance and the efficiency of the Pelton turbine. Let's go. So there is a experiment procedure. First, the Pelton turbine, as we seen the figure above, both of the figure. This is in the lab and this is a schematic diagram. So the Pelton turbine test. Bench was set up on the table and they make sure all the parts are functioning properly, which is a switch, sensor. We use a tachometer sensor and the flow meter sensor. So the second is the stretch belt sensor. It must be connected. It's back behind the Pelton wheel. The sensor must need to the Pelton turbine connection. So third is the tachometer sensor and the flow meter sensor must be checked and functioning well. So we must to avoid the error by using a daisy leg. So the Pelton turbine was switched on. We must switch on usually we switch on pump and the water valve. This is water valve, and we know it's a sphere. We must to loosen it to make a diameter of the nozzle become close or big, depend on the different speed. So the fifth is the daisy leg. All the sensor and the reading from the sensor into the daisy leg to make the calibration and the scaling process to eliminate any possible error in digital meter reading for the strain gauge and the flow meter sensor. So after we check with a different speed of the water, flow rate water, then the data will be obtained and the record and being tabulated for the data will be recorded and at the result. Thank you.
Hello, my name is Baselin and my metric number is MA170099. I'm going to present the results of the experiment. This is the first result, which is the flow rate of the water is 30.9 liter per minute. And this is the second one, which is the flow rate of the water is 11.75 liter per minute. This is the example of the calculation for this experiment, which is the first what we calculate is the theoretical power input of the turbine, which is we use this formula power input is equal to density time flow rate time gravitational constant and water head. And the second one is the power output, which is we use this formula, which is P equal to 2 pi times the rotational speed and the moment of the shaft. And last one is the total efficiency of the turbine, which is from the previous calculation we use the power output divide by the power input and time by 100, which is in the efficiency is in percent. For discussion from the two graphs, it can be concluded that the increase of the moment of the shaft will decrease the rotational speed of the turbine, and therefore the decreasing value of the rotational speed is depend on the value of the flow rate, which is from the first graph we can see where the volume flow rate is 30 liter per minute, and the decrease of the rotational speed is slower compared to the second one, which is the flow rate is 11.75 liter per minute, where we can see the graph is the graph shows that decrease in rotational speed is very fast. Last one, from the graph we can see that the higher flow rate of water will give the higher power efficiency of the turbine. And that's all from me. Thank you.
Assalamu alaikum, my name is Hussein Abdul Karim, and today I'm going to present you my part, which is a conclusion. So, in conclusion, we have learned to design complete measurement technique for fluid flow. The measurement technique used in this experiment is by using DigiLab software. Sensors are synchronized with the apparatus to obtain accurate data with less error. Besides that, we have learned to determine the performance and the efficiency of Pelton turbine at the different operating conditions. At the same time, several parameters such as head, pressure, power output, and efficiency has been studied. Is compared with both conditions. There are two operating conditions. Conditions are used: half open nozzle and full open nozzle. From this experiment, we can include that the half open nozzle is more efficient than the full open nozzle. This is because the high velocity produced in nozzle jet causes the Pelton wheel to rotate the high revolution per minute and causes a high magnitude in the angular velocity. The high angular velocity produces high torque in the Pelton wheel. As I know, the torque is directly proportional to power output. The higher the torque of Pelton wheel, the higher the power output we gain from the Pelton turbine. Thus, it causes the efficiency. In the half open nozzle becomes higher. There is a small loss of efficiency in the system. The efficiency lost is caused by mechanical friction, aerodynamics, drag on the bucket, friction in the bucket, and losses in the nozzle. So all kinds of losses have to be avoided in order to produce a system with minimum loss with optimum efficiency. And there are the reference, and that's all from me, and thank you.